Imagine you want to take a picture of something far away. You could use a camera. But what if it's cloudy? What if it's nighttime? That's where ASAR comes in. ASAR stands for Advanced Synthetic Aperture Radar. It's a special kind of radar that can see through clouds and darkness. ASAR is used on satellites that orbit Earth. These satellites send out radar signals and listen for the echoes. By analysing these echoes, we can create detailed images of the Earth's surface. ASAR is a powerful tool for understanding our planet. It helps us track changes in the environment, monitor natural disasters, and even find resources like oil and gas. ASAR works by sending out pulses of radio waves from a satellite. These pulses travel down to Earth and hit the surface. Some of the waves bounce back up to the satellite. Imagine you throw a ball at a wall. The ball bounces back to you. ASAR is similar, but instead of a ball, it uses radio waves. The satellite's antenna sends out many pulses as it moves along its orbit. By combining the echoes from all these pulses, ASAR can create a much more detailed image than a single pulse could provide. When the radar pulses return to the satellite, they are used to create an image. The brightness of each pixel in the image corresponds to how strong the radar echo was from that location. Different surfaces reflect radar waves differently. For example, water reflects radar waves weakly, so it appears dark in ASAR images. Rough surfaces, like forests, reflect radar waves strongly, so they appear bright. By analysing the patterns of brightness and darkness in ASAR images, scientists can learn a lot about the Earth's surface. They can identify different types of land cover, track the movement of ships, and even monitor the growth of crops. One of the biggest advantages of ASAR is that it can see through clouds. This is because radio waves, unlike visible light, can pass through clouds without being scattered. This makes ASAR an invaluable tool for monitoring weather patterns, especially in areas that are frequently covered by clouds. For example, ASAR can be used to track the movement of hurricanes, even when they are obscured by thick cloud cover. ASAR's ability to see through clouds also makes it useful for monitoring remote areas that are difficult to access by plane or on foot, such as dense rainforests or polar ice caps. Section 5. Helping our planet. ASAR, or Advanced Synthetic Aperture Radar, has many applications that can benefit our planet and its inhabitants in numerous ways. One of the most important applications is environmental monitoring, which is crucial for maintaining the health of our ecosystems. ASAR can be used to track deforestation, monitor oil spills, and detect other environmental hazards. It can also assess the health of crops, ensuring food security and sustainable agricultural practices. For example, ASAR images can be used to identify areas where illegal logging is taking place, providing critical data for conservation efforts. This information can then be used to help authorities crack down on these activities and protect our forests, preserving biodiversity. ASAR can also be used to monitor the melting of glaciers and ice caps, which is a major concern due to climate change and global warming. By observing these changes over time, scientists can gather valuable data. By tracking these changes over time, they can analyze trends and predict future impacts. Scientists can better understand the impacts of climate change on our planet's delicate balance. This knowledge helps in developing strategies to mitigate its effects, such as renewable energy solutions and conservation policies. Section 6. Watching for danger. ASAR also plays a crucial role in disaster management. It can be used to monitor natural disasters such as earthquakes, floods, and volcanic eruptions. ASAR data can help rescue workers assess the damage, locate survivors, and plan relief efforts. For example, after an earthquake, ASAR images can be used to identify areas where buildings have collapsed or where landslides have occurred. This information can help rescue workers prioritize their efforts and reach those in need more quickly. ASAR can also be used to monitor volcanic activity and provide early warning of eruptions. This can give people living in vulnerable areas time to evacuate and minimize the loss of life and property. Section 7. ASAR in action. Real-world examples. One compelling example of ASAR in action is its use in monitoring the Amazon rainforest. This vast and vital ecosystem is often under threat from various human activities, making it crucial to have advanced monitoring systems in place. Illegal logging is a major problem in the Amazon, and ASAR provides a way to track this activity even in cloudy conditions. Traditional monitoring methods often fail due to the dense cloud cover, but ASAR can penetrate through and provide clear images. In 2023, ASAR images revealed a surge in illegal logging in the Brazilian Amazon. These images were instrumental in highlighting the areas most affected by this destructive activity. The images showed large swaths of forest that had been cleared, even within protected areas. This was a significant finding, as it indicated that illegal loggers were not deterred by conservation efforts. This information prompted the Brazilian government to take action against the illegal loggers. They launched a series of operations to crack down on these activities, using the ASAR data as a guide. Another example is the use of ASAR in the aftermath of the 2010 Haiti earthquake. This devastating event left the country in ruins, and quick response was essential. ASAR images were used to identify collapsed buildings and blocked roads, which helped rescue workers reach survivors more quickly. The ability to see through debris and obstructions was invaluable in these critical moments. The images also revealed the extent of the damage to infrastructure, such as roads, bridges, and airports. This comprehensive view allowed for better planning and resource allocation. This information was crucial for planning relief efforts and delivering aid to those in need. By providing accurate and timely data, ASAR played a key role in the disaster response and recovery process. Section 8. The Future of ASAR. ASAR technology is constantly evolving, pushing the boundaries of what we thought was possible. Scientists and engineers are tirelessly working on developing new ASAR systems with even higher resolution and greater sensitivity, aiming to capture the finest details. One particularly promising area of research is the development of miniaturized ASAR sensors that can be mounted on drones, making them more versatile. This innovation would allow for more targeted and flexible data collection, especially in disaster zones or other hard-to-reach areas, providing critical information when it's needed most. Another exciting area of development is the integration of artificial intelligence into ASAR data analysis, which is set to revolutionize the field. AI algorithms can be trained to automatically identify patterns and anomalies in ASAR images, which could greatly speed up the process of data interpretation and decision-making, making it more efficient and accurate. The future of ASAR is indeed bright. filled with endless possibilities and innovations. As technology continues to advance at a rapid pace, we can expect ASAR to play an even greater role in understanding our planet, managing resources, and responding to disasters, ultimately making our world a safer and more informed place.